All right, so welcome to the exam 2 for MGF 1106. This is coming to you live and in living color from the online math resources for students. Okay, so if you're in this course, then you know that if you open it up, eventually when the computer thinks about its life, and you go into my college mathematics, which should be right here. And right here under test review materials, you will see that I have already placed out here the blank review for version A. Right here is a solution. It's not a solution. It's just the solutions. It's not a solution guide. But we're going to be working on that solution guide right now. And over here is where we will post the video once we have completed this, well, basically this review session. So right here is another review session that we have done in past semesters. So if you want to take a look at it, it's pretty much almost the same as this. The only thing that has changed is the numbers. So it's the same concepts all the way through, just the numbers have changed. Okay, so here are two different reviews for this. All right, so with that being said, let's kick this party into high gear and let's start talking about some college mathematics. So here is our review. So the first thing that I can tell you is all of the chapter 9 information, you should not have to memorize any conversions or anything like that, because right over here in this small little box, they give you all the information that you need, okay, for any conversions that you need throughout the exam. So keep that in mind. And with that being said, let's start with number 1. And as we go through this, I'm roughly going to try and tell you where everything's coming from, and we'll be good to go. So number 1, this is coming from 9-1. We're converting distance, and we want to take 0.013 millimeters, and we want to change it to meters. So how are we going to do that? What do we got to do?
Move the decimal to the left.
How many times?
3.
3. You got it. That's one way of doing it. Okay. So we start right here at millimeters and we take 1, 2, 3. And the direction you're moving to the left means that you also move the decimal to the left. So we've got this number right here. And we're going to take this decimal and we're going to move it to the left 3 times. So we're going to go 1, 2, and 3. Put our decimal back in. And what's going to go in all these blanks here?
Zeros.
Zeros, yes. And so there's our number. So this is 0.00, 4 zeros, 0.0013 meters. There's your answer. Another way you could have done this, let's talk about this real quick, is you could have just taken our number and divided it by 10 3 times, because that's also what it says to do in the drawing. See right here, you move to the left. For each step, divide by 10. Okay? So I've got my calculator. So all we really need to do is take this number right here, 0.013, and divide by 10, divide by 10, divide by 10. Okay? So we go to our calculator, 0.013, and you just hit divide by 10. And then you divide by 10. And then divide by 10. But notice what happened in the end. What is this E that's there. So that's what we got. What does this E represent? Anybody?
Equivalent?
Not equivalent, but that is a good guess, April. When your calculator kicks out an E like this, it means it's scientific notation. That the answer was so small for it, even though it can actually show this answer if it really wanted to. But they put it into scientific notation. That E represents times 10. This -5 is the power on the 10. Okay? So this E represents that piece right there. The problem is, in my math lab, it doesn't want this. It wants the decimal. So if you go this route, that means you're going to have to take and you're going to have to move the decimal 5 places to the left. That's what a negative exponent means. Move decimal 5 places to the left. Actually, I didn't want to write out 5 places. Just wanted to write out in general. What did the negative exponent mean? Move decimal to the left. Let's just take that piece out. So whenever you have a negative exponent on scientific notation, it means move the decimal to, this is why we don't write in pen. The left. And I'll give that a second to dry. So we go 1, 2, 3, 4, 5. And then there's that same number. So my advice to you, you can use the calculator. There's nothing wrong with it. But I would just move the decimal from the very beginning. Because sometimes the calculator will kick out that weird scientific notation. Okay? But that's the answer. That's what it wants. Do not put scientific notation into my math lab. All right, number 2. Moving on. Okay, so it says use the English and metric equivalents to the right along with dimensional analysis to convert. So we're converting 21 centimeters and we want to turn it into inches. So over here, what is the conversion we need to use?
The 1 inch equals 2.54 centimeters.
All right, exactly right. 1 inch equals 2.54 centimeters. Thank you, Abigail.
Sure.
And also, again, just like in the chapters for chapter 9, can't stress this enough, make sure that you read the fine print because this says round to the nearest hundredth. The first one said write it as an integer or a decimal. So make sure that you're always reading that fine print there. So as we jump over here, here is that conversion we talked about. And when we do dimensional analysis, we use what is called the unit fraction. So what label will go in the denominator?
Centimeters goes in the denominator.
That's right, because that's the one we're getting rid of. The label you're getting rid of goes in the denominator. That means inches in the top. So now you know which number goes where. 1 will go in the numerator, 2.54 in the denominator. And all I do is go to my handy dandy calculator, let it do the hard work for me. So we go 21 times, where's our fraction key? Where is our best friend? How do I make a fraction in my calculator?
You divide?
How about alpha y equals? Alpha y equals is your best friend in the calculator. Because when you do that, these are all your fraction keys. And we're always going to use number 1. See, look, looks just like the fraction that we wrote. All you got to do is put the 1 on top and the 2.54. Now, what you said, April, is just fine. You can use the division because fraction, all it is division. Just make sure that you put a parenthesis and then put 1 divided by 2.54, close the parenthesis.
That's what I do, because my calculator doesn't seem to have the fraction thing that yours does.
Are you on an 83?
I'm on a Texas Instruments T30X.
Okay, so yeah. Okay. Yeah. Just put it in parentheses. All right, and then you hit enter, and there's our number. Again, the directions say to round to the nearest hundredth. So what is the answer?
8.27.
Perfect, Abigail. I love it. Because this 7 right here says, hey, 6, go up. And there you go, 8.27. Moving on. Number 3. Now, in your assignments, you didn't really have anything that had 2 labels to it. But don't let the 2 labels throw you off on this. In here, it says we are going 60 miles per hour. They want you to convert this into kilometers per hour. So if we look at this just kind of written out, what I just said, it looks like this. Does this second label of hours really matter to us?
No.
No. It's the same on both of these. So we're not changing that. The only thing that we're really focusing on is changing miles to kilometers. So don't worry about this hours. Worry about changing miles to kilometers. So let's jump back. What is going to be the conversion we need in here?
The 1 mile is, where'd it go? 1.6 kilometers.
Yay. That's exactly what we need. So when we come out here, we'll make our unit fraction. What label's on the bottom?
Miles.
Miles, because we're getting rid of miles. Well, then that means kilometers in the top, and now you know where the numbers go. 1.6 on top and 1 on the bottom. And we go to our handy dandy calculator and we multiply. 60 times 1.6. You don't need to make this a fraction because it's over 1. It's not going to change anything. And there it is. The directions did say round to the nearest whole number. Do I have to do any rounding on this? Do we have to round this?
No.
No, it's good to go. It's already a whole number. So you just write 96 kilometers per hour. There we go. Nothing crazy. You guys got this. You're doing great. All right. Question number 4. So use the table along with dimensional analysis to convert the square units to the square units, okay? Just so you know, everything from question 1 through 3, that was all, excuse me, 9-1. Question 4 starts 9-2. Okay. So 1, 2, and 3 were 9-1. Question 4 is 9-2. So we have this 17.9 HA, which I call it a hectare. And we want to convert that to acres. So what is the conversion we need from our chart over here? What's our conversion that we need?
The 1 acre is 0.4 hectare.
You got it. You got it. 1 acre equals 0.4 ha or hectare. Okay. So when we think about dimensional analysis, what label goes in the denominator?
Acre.
Careful.
Or
Who are we getting rid of?
the hectare.
The hectare.
Oh, I'm sorry. I thought you said numerator. I just wasn't paying.
Nope. No, it's okay. So
Gotcha.
now we know that acre.
I wrote it right. I just said it wrong.
No worries. So the 1's up top and the 0.4 down at the bottom. And then we just go to our handy dandy calculator and we do some quick multiplying. 17.9 times, where's our best friend, the fraction?
Alpha y equals.
Alpha y equals 1 over 0.4. And directions, what did it say? Ooh, we should have looked at that. Nearest hundredth. So do I have to round this?
No.
No, because it's already at the 100th here with the 5. And there you go, 44.75. Number 5. So number 5, we have a swimming pool that has a volume of 45,107 cubic feet. And we want to turn this into gallons. Now, notice down below, well, there's a little bit of a fix on this because there's two parts to this question. One, we want to know how many gallons is it, and 2, which one of these is the label. Okay, so right away we can answer the label question. They say we want gallons, so which label are we going to choose?
Cubic?
Gallons.
Not cubic gallons. It's not cubic.
Square?
It's not square either.
Just the regular gallons.
Just the regular gallons right there. I mean, the label says how many gallons. If it wanted square gallons, it would have said how many square gallons. If it wanted cubic gallons, it would have said how many cubic gallons. I mean, the label is just galleons. Okay? Or not galleons, gallons. So there's one part of your answer. Now all we got to do is figure out how many gallons it is. So which idea over here, which dimensional analysis or unit fraction are we going to use? What's the relationship we need?
The 1 cubic foot to 7.48 gallons.
There you go. 1 cubic foot is equal to 7.48 gallons.
Wait, do you divide or multiply?
We're going to multiply by the unit fraction, just like always.
Okay.
What number goes, or sorry, not number, what label is in our denominator?
Cubic feet.
Yippers. That means gallons is in the top. So you now know that 1 goes in the bottom and 7.48 is in the top. So I get what you were asking, April. Yeah, and this one, because our denominator is 1, we can just do straight multiplying. Actually, we always multiply. It just depends on whether we want to turn it into a fraction or not. So we're going to take the 45,107, and we're going to multiply that by 7.48. I could make this a fraction and put 7.48 over 1, but it's not going to change the number. And hit enter. There's what we know. Let's see what it says for the directions. It says round to the nearest whole number.
Yeah.
So to the nearest
I
whole
haven't gotten a
number.
message back from her yet, and she said after 10:30. So relax. Okay.
So to the nearest whole number, what is our answer? What is our answer to the nearest whole number?
Does that mean to make the last number at the end one number more than was and not have the ones after this?
What whole number means is that there are no decimals.
Yeah, that's what I meant. So it would be 337401.
Nope, because the 3 doesn't say go up. What does the 3 say? 3 says stay the way you are. So 337,400. Okay? Remember, 4 and below, leave it alone. 5 and above, take it up. Careful on those rounding. So don't forget on this one, again, there's 2 answers that are here. We're just missing the blank for the number. So the number is 337,400. And then you'll select A as the label because it just wants gallons. All right, number 6 is just like number 1. The instructor who made this was nice enough to give you this little picture right here. But just so you know, on the exam, they do not give you this little picture for it. I don't know why. They should, but they don't. But just so you know, if you need a picture to go back and look at this, just go back and look at question number 1. It's the same picture. All we did was changed all these M's to G's because it's grams. Okay. Volume is coming to us from 9.2 as well. I believe volume is in 9.2 as well. Yeah. Okay. So we are going from 680 milligrams, and we want to turn this into grams. What are we going to do?
Move the decimal 3 places to the left.
That's right. Same thing again. So we're going to take 680 and we're going to move the decimal 3 places to the left. Where is the decimal at on this right now?
It's on the far right.
That's
so you just
right.
move it 3 places to the left. So now it's 0.680.
You got it. So 1, 2, 3. There's my new decimal. So in grams, it's 0.68. If you want to put the 0 on there, there's nothing wrong with that. You don't have to if you don't want to. So you can say 0.68 or 0.68. 680 grams. And again, the other way that you can do this is you can take the 680 and divide by 10. That's a horrible looking 10. And then divide by 10 again and divide by 10.
Question, will MathLab mark it as wrong if I do it as 0680 instead of as 0.6 or something?
It shouldn't. It should not. Okay, and the cool thing with this one is the calculator will not give you scientific notation on it this time. So if you go to the calculator and you take 680 divided by 10, divided by 10, divided by 10. And there's our number. And there you go. Okay, two ways to do it, just like before. Nothing new on number 6. Number 7. Number 7 and number 8 are temperature conversions. So you are still in 9-3 on this. So number 7 and number 8 are still conversions. So they give you the formula, so you don't have to memorize the formulas. You just got to pick the right one. So we have 28 degrees Celsius. Which formula up here should we be using? The C equals 5/9 parenthesis F minus 32 parenthesis, or the F equals 9/5 C plus 32?
Second one?
The second one, absolutely, because we want Fahrenheit, and this one is equal to Fahrenheit. So we're going to use the formula F equals 9/5 C plus 32. So all you're doing on this is plug and chug. We're going to take this 28, we're going to put it in for C. So F equals 9/5 parenthesis 28 parenthesis plus 32. Just let your calculator do the work for you. Put this in exactly the way you see it. So we go to our calculator. Alpha y equals 9/5, 9/5, parenthesis 28, close the parenthesis, plus 32. That is exactly the way I had it written on my paper. My calculator will take care of all this for me doing the PEMDAS. And there it is. But again, in this, it says we want our answer to the nearest tenth. So we don't want a fraction. So how do I get this answer into its decimal? What are we going to do? How do I... Yeah, keep going, April.
I'm not sure if what I'm doing is correct, but what I do is, so I put the 28 over 1, I multiply 28 times 9, then I divide by 5, and then add the answer by 32.
Yeah, you can do that too. That absolutely.
I got 82.4, is that correct?
Well, tell me, how can I turn this fraction back into its decimal? What are we going to do?
You mean like the 9 over 5?
No, don't worry about this stuff. How can I turn this back into its decimal? If I got 412 over 5, how can I make that a decimal?
Divide?
Yeah, just do the division. That's all a fraction is. Take 412 divided by 5. So I got 82.4. April, did that match you?
Yes.
There you go. And do I need to round this any? Again, the direction said to the nearest tenth. Do we need to round that any?
I don't think so, but I'm probably wrong.
Nope, you're correct.
Oh.
It is already at the nearest tenth. Tenth is 1 decimal place. So 28 degrees Celsius is 82.4 degrees Fahrenheit. Number 8 works the same way. This time, you have 92 degrees Fahrenheit. We want Celsius. Which formula will we use?
Oh, the first one?
The first one, C equals 5/9, parenthesis F minus 32. So all you got to do again is plug in 5/9, parenthesis 92 minus 32, close the parenthesis. And so we go to our calculator, we'll put it in just like how we see it. So we'll hit alpha y equals 5/9, parenthesis 92 minus 32. And there it is. How do I turn that back into the decimal? How do I turn that back into the decimal? Come on. How do I turn 100/3
Divide.
into the divide? There we go. Yeah, just divide. 100 divided by 3. There it is. And it says round to the nearest tenth. So what is my answer?
That'd be 33.4, right?
No.
Oh, whoops.
Rounding. Rounding's going to kick your booty, April, if you're not careful. It's not 33.4. What is it?
33.3?
Yes. There you go. 33.3 degrees Celsius. Any questions on everything so far? All right. Let's talk about number 9. Because number 9, if I remember right, take a look at it. Yes, this one tends to trip people up. Okay. So there are 2 questions here. Let's talk about what we know so far. Okay. So it says a label on a bottle of medicine reads, each 5 milliliter teaspoon contains glucose. Okay, so I'm going to write some stuff down. 5 milliliters, we have glucose. And that is 1.87 grams. We have, I just call this Leviosa because I know it's probably like Levuus. I don't know. I just call it Leviosa. So Leviosa of 1.87 grams. And then we have phosphoric acid. And that is 22.2 milligrams. Okay. So we read the side of the bottle, and that's what we know about some of the ingredients in it. So part A says, find the amount of phosphoric acid in the recommended dosage of 2 teaspoons.
I think what you're supposed to do is convert the ones that aren't milligrams to milligrams.
Hold on. All right. So right now we know that in 5 milliliters, which is a teaspoon, we've got this information. So we want to know about phosphoric acid. How much is in 2 teaspoons? Well, what do you, so April, you said we wanted to do what first?
Turn the glucose in the levulose to milligrams.
Nope, we don't have to change those. They can stay grams. Again, remember, we're just after phosphoric acid. So if this is in 1 teaspoon, 5 milliliters, it's 22.2 grams. How much is 2 teaspoons? What do you think?
44.4.
You got it. 44.4 milligrams. How'd you get that, Abigail?
Um, hold on. I did something weird to my computer.
That happens to me all the time.
Okay, sorry, I didn't know if you guys could hear me. It doesn't show me anything at the moment. Just multiplied by 2 because we're going from 1 teaspoon to 2.
That's right. We're just doubling it.
I don't know what happened.
Okay. Or another way you think about it, like you take 1 teaspoon and then you take another. So it's just like adding the ingredients together. 22.2 plus 22.2, 44.4. Or in other words, just like what Abigail said, multiply it by 2. So I know we didn't ask about glucose or leviosa, but how much is there for those? I always like to fill in everything. So if we doubled the recipe, so in other words, it just appease me. If we have 2 teaspoons, how many milliliters is that?
10.
10, because it's just doubled. 5 times 2 is 10. 22.2 times 2 is 44.4. So how much leviosa and glucose do we have if we multiply by 2?
3.74 grams.
Yay. Again, we didn't need those pieces of information, but I want you to see that if you just double something, all you're doing, if you're doubling a recipe, all you're doing is multiplying all the ingredients by 2. It's kind of like a cooking idea with this one. So that's part A, and that's what you were looking for right there. 44.4 milligrams. All right, now part B. Part B says if the bottle contains 6 ounces. Okay. They want to know how much phosphoric is in the bottle. Okay. And they give you a little hint right here with a conversion. So we definitely need this guy. 1 ounce is about 30 milliliters.
Could you just multiply all those other answers by 3?
Why by 3?
If you're going from 10 milliliters to 30 in the 2 teaspoon one.
Am I going from 10 milliliters to 30?
I thought it said 30 milliliters. Oh, I'm sorry, the 1 ounce. Nothing, I misread something. Okay.
So we have 6 ounces. What should we do with the 6
Yeah,
ounces real quick?
I was thinking it was 1 ounce. Convert it to milliliters.
Yes, we need to convert that to milliliters real quick. So here we've got this conversion that will help us. So what label goes in the denominator? Who?
Ounces?
Ounces. And milliliters will be in the numerator. So now you know that the 1 goes with the ounces and the 30 goes with the milliliters. So in the end, in that bottle, there are 180 milliliters. Do you know how many teaspoons that is?
$36.
36. because you take 180 divided by 5 because 1 teaspoon is 5 milliliters. So how are we going to get the phosphoric acid then? How are we going to get this answer? We have everything we need now. What can we do? Two ways to approach this.
Multiply by 18.
To who?
I mean, the values from the 2 tablespoon 10 milliliter one, or we could.
You got it. We could multiply these by 18 to jump from 10 milliliters to 180. Because if I take 18 times 10, I get 180 milliliters. Okay? So we can multiply these by 18, or what can we multiply these by?
$36.
36. Yeah, or you can multiply these by 36 to get all the same answers. Okay, but I like to take the 3.74 and multiply it by 18. So I know we didn't ask about them, but how many glucose and Leviosa grams are there?
I guess you have to add both 187s together.
Say it again.
You have to add them together.
No. Take these numbers, because we're going from 10 milliliters to 180 milliliters, and you're going to multiply it by 18. Multiply this by 18. Multiply by 18. Multiply by 18. So how many glucose grams are there?
67.32.
Yeah, I know we didn't ask about it, but I always like to show you that it's the same process. And so that means Leviosa has 67.32 grams as well. How much phosphoric acid is there?
799.2.
Yep. And that's milligrams. So all this problem was about was like doubling your recipe, or in the end, massively increasing the amount in your recipe. So from 5 milliliters to 10 milliliters, all we had to do was double the ingredients. But when we're going from 5 milliliters to 180 milliliters, we needed to multiply our original recipe by 36. Take all these and multiply it by 36. Or another way to think about it is, if you know what a doubled recipe is, to get up to 180, you multiply it by 18. So that's all this was about, was taking regular ingredient, and it's like you're going to make the ingredient, you're going to make a lot more than what you thought you were. Okay? So to get from the original to A, we multiplied by 2. To get from the original to B, we multiplied by 36. Or to get from A to B, you multiply by 18. Careful on number 9. That's one that generally throws students off. And that right there stops chapter 9. And again, I don't know why I have it set up this way. I just need to go in and correct it. But that stops chapter 9. And we will come back to chapter 9 starting at question number 23. Okay? For some reason, I've got 3 questions at the end that go back to chapter 9. But for right now, questions 1 through 9 are all chapter 9. Question 10 starts chapter 10. All right. Question 10, part A and part B. There are 2 questions here. What is the complement? Not as in like, oh, you look smashing today. Not that kind of compliment. And then what is the supplement? Of a given angle 4 degrees. What does complement mean? So if I got this 4-degree angle, how do I find the complement for it?
Okay, so I might be wrong because I don't remember much of this. I haven't actually studied in a while, sorry. But I think you subtract 4 from 90, and the complement is the stuff they have left over.
You got it.
Oh.
Complement means that it's two angles that add to 90. So complement is all about two angles that add together that will equal 90. So basically they're asking what plus 4 degrees equals 90 degrees. And so that missing angle is what we're looking for.
Is that the 86 degrees?
So 86 degrees. So just like what you said, we're going to take 90 minus the 4. So our complementary angle is 86 degrees, because 86 degrees plus 4 degrees gives me 90 degrees. What's supplement then? What is supplement for us? What is
Supplement's 176.
And how did you get that? What is
180 minus 4.
There you go. So supplement is all about two angles that add and equal 180 degrees. So what plus 4 degrees equals 180 degrees, and you gave it to me 176 degrees. That is the supplement angle. Perfect. That's all they want in number 10. Number 11. So this is also one that sometimes trips students up. So you just got to be careful. So we have these two parallel lines. And then we've got all these angles we want to know about. Give me a second as I write down what we're looking for. Okay. So right in here, there's an X, but up in the directions they tell you that that X is 98. So I'm going to go ahead and put the 98 right in here for X. And then we're going to find all these other missing angles. So here is what we know. So what are some angles that we know now?
One and 4.
Well, what do we know about 1 and 4?
1 is going to be the supplement to.
Supplements to 98.
Yeah, right? Because these two are what we call that linear pair relationship. They form a straight line right there. So absolutely, what plus 98 will give us 180?
82.
Okay. So you now know that angle 1 is 82 degrees, which you can come out here and put that information. We know that that's 82 degrees. We can keep using that. Okay, you said that we know angle 4. What does angle 4 got to be?
98. Because they're
Why?
They're parallel, I think. Yeah,
And that's because of the parallel lines. These are my parallel lines. And they should have marked it in the picture. Our book does a horrible job of showing you things that are parallel. They're making you assume some things, which assuming in geometry is horrible. You never assume things in geometry. So these are my parallel lines, and because these are parallel, these two have to be the same angle because they are what we call corresponding. These are corresponding. They're in the same spot. Top left-hand corner, top left-hand corner. So this is also 98 degrees. So I write that in, and we can now use that. Who else do we now know? We got 5 other angles.
We know number 5 is parallel to number 1, I think.
So we've got 2 angles right here, 5 and 1. And because they're parallel lines, we know that these 2 angles have to be the same, right? Again, they're corresponding, just like the 98 and the 98 here. These 2 angles are corresponding. This is in the top right, top right. So what must angle 5 measure? How much is angle 5?
Sorry, 82?
Yep. So 82 degrees. Okay, we'll put that in there. Who else do we now know? 4 more angles.
So we have to figure out the ones in the bottom. The ones below the things. So I might be remembering this correctly, but what 98 and 3 also be parallel because they're directly opposite of each other?
Yeah, these two, not parallel, but we call those congruent.
Congruent,
These
yeah,
two are
sorry.
the same because these are what we call vertical angles. And vertical angles are always congruent. So measure of angle 3 is also how many degrees?
38?
98. So we can
Yes,
put
so
98 degrees there.
so is angle 7 because that's congruent with
Angle 7 is congruent with
angle 4.
angle 4. Yep, because these are vertical. They're across from each other. So angle 7 is also 98 degrees. Now, who else do we know? We only got 2 angles left. We got 2 and we got 6.
Well, 2 and 1 congruent, so 2 is also 82, and 6 is 82, it's congruent with 5.
You got it. Again, vertical angles. Vertical angles are always congruent. So this is 82 degrees. And vertical angles again. This is 82 degrees. There you go. There's all of the answers. So 82 degrees, 82 degrees, 98 degrees, 98 degrees, 82 degrees, 82 degrees, 98 degrees. There you go. All right. Moving on. Number 12. So we've got this triangle here, and we want to know what is the measure of angle A. How do we do that? How are we going to find the measure of angle A? What do you know?
Are we talking about Pythagorean theorem?
Nope. This isn't a right triangle.
All right. Don't all right triangles equal 90 degrees?
Did you say all right triangles?
Or this one, at least?
What do all the angles do?
Equal 90 degrees?
Nope.
No, I mean,
but you're close. All the angles do something.
yeah, sorry, I don't know. I just woke up and I'm so tired.
It's okay. All my angles are going to add to something. What should they add to?
180?
Yes. All the angles inside my triangle must add to 180. So all we have to do is subtract the 24 and subtract the 39. So 180 minus 24 minus 39 gives us what?
117?
There you go. That's the measure of angle A, 117 degrees. Because all you got to do is subtract the 24 and subtract the 39. All right, number 13, moving on. Again, all this is still in, 10 and 11 were all 10-1. Number 12 is starting on 10-2. And number 13 and 14 all come from 10-2. Yeah. Okay. So, number 13 says you're going to use the Pythagorean theorem. What is the Pythagorean theorem?
A squared plus B squared equals C squared?
You got it. A squared plus B squared equals C squared. Now, real quick, we know which one of these we should select right away just based on the labels. So this answer, it kind of comes in two forms. One, we got to figure out the length, and then two, you got to make sure that you select the correct label. Everything over here on this diagram is centimeters. So which one do you think we're going to pick? A, B, or C? We're just looking for a length.
So we have to convert the answer we got to meters.
But all these answers over here are in centimeters. Would you really want to convert?
I don't know. I got 180 centimeters squared.
We'll get to numbers here in a second. Let's just focus in on the label. If these are in centimeters, would I really want to convert them to meters?
No.
No. So we're not going to convert to meters. None of that junk.
Oh, is the answer B?
Yes, we're going to go with B because all we want to do is find the length in centimeters. So you know that you're going to select B. All we got to do is figure out the number that goes in there. Okay? Yeah. Don't go changing the length to meters. That's just crazy. In centimeters squared, which was the choice C, this is about area. And we're not finding area. We're just looking for how long is this? So that's why we're going to choose B. So let's plug in. This guy was actually A. So we'll plug that in for A. So who over here is the B?
The base? You know,
No, B doesn't stand for base. This is Pythagorean theorem. Careful.
the one on top?
The one on top. This is your B. And they should put this in there just to make sure that we know that this is a right triangle. Because again, it's making us assume. So this is the right angle. And remember that A and B are what we call the legs. And the legs are always connected to that symbol. Leg, leg. So the B is 12 squared, and that means this guy right here is your C, because the C represents the hypotenuse. So there we go. So we need to do some squaring now. So what is 12 squared? What's 12 squared? Come on, help me out here, please. What's 12 squared?
144.
There we go. And 18 squared is 324. What are we going to do now?
Take 144 away from 324, and the answer
You got it.
is that.
All right. So we get x squared equal to, if we subtract that from both sides, the 144, you get 180. And now what do we do? Because you're not done. The answer is not 180.
You get the square root of 180.
Yeah, we got to take the square root of both sides, because that's how we get rid of something squared. And x is equal to, let's take a look real quick. It says to round to 1 decimal place. So if you go into your calculator and you hit second square root 180, round to 1 decimal place, what do we get? Rounded to 1 decimal place.
Is it 13?
1 decimal place. So it's not 13. It's 13 point what?
Oh, 13.4?
You got it. So you select answer B, and you put 13.4 in the blank. And there you go. All right, number 14. We're using similar triangles here, and they gave us a nice, lovely picture with the tree, and then where we're standing. And then what the sun is doing to us. Sorry, just recopying things back down. In the end, they want to know, what is the height of the tree? Okay, so real quick, we can figure out which one of these we should select. Everything in this picture is all about feet. So which answer should we select? A, B, or C?
Middle one?
The middle one. Absolutely. The one with feet. That's what makes sense. Okay? So, now, how are we going to find the height of the tree? Again, the direction said use similar triangles. Do you see 2 triangles in this picture?
Yes.
Yes. Okay. So hopefully you see a large triangle and a small triangle. Talk to me about the large one. Do we know this length right here?
Nope.
That's what we're looking for. That's our tree. Do we know this length?
It's 140?
Nope.
Oh, no.
Nope. This length right here is that little line that's right there. We don't know that
Oh.
length. Do we know the bottom length?
The bottom length is 140?
That's your 140. Because you take the 126 plus the 14, and that should be feet. So there's the big triangle. Now let's talk about the small triangle. Do we know this length right here?
Yes, it's 5.
There you go. Do we know this bottom length?
It's 14.
Mm-hmm. And then obviously we don't know the hypotenuse length because that's right there. So now all you do to solve this is you set up a proportion where we either go from the big triangle and compare to the small one, or we compare the small to the big. April, I will let you do the honors. Which one do you want to do? Small to big or big to small? How do you want to compare?
How about small, big?
Okay. So that's how we're going to make our fractions. So give me a number on the small.
5.
5. All right. Give me whatever matches it on the big. So who matches the 5?
We don't have what matches 5, and we don't really know what it is.
But there's a variable there, so it's the x.
All right.
All right. Now give me another number on the small.
14.
Who matches it on the big?
140.
And there you go. All we got to do is solve this. How do we solve proportions?
Do we cross multiply?
You got it. So we're going to take 5 times 140, which is 700, equal to x times 14, which is 14x. How do I solve that?
You divide by 14.
Perfect.
So x is 50.
So x is what?
50.
50 feet, which is choice B. So we select choice B, and we put in 50 in the blank. And there you go. Number 15. We're almost done. Yay. All right. So number 15. This is where we get into 10-3. And really 10-3, 10-4, and 10-5 are all about formulas and things like that. Okay? 10-3 is all about perimeter. 10-4 is about area. 10-5 is about volume. Okay? So 10-3, first thing is they give us this triangle and they say find the perimeter. What does perimeter mean?
Well, the measure of all the sides.
Yeah, you measure all the sides. You add up all the sides. What is our label in the end of this going to be?
Feet.
Feet. So we're going to select B, and then we're going to add up all of our numbers and put that in there. So all we got to do is take 27 plus 20 plus 9. And what does that give us?
56.
So 56 feet. So you select B and you put 56 in there. All right. 16. Again, another perimeter problem. Let me draw this picture out real quick. Give me just a moment. Okay. Again, We're looking for perimeter. All this is measured in feet. Which label or which one should we select over here? A, B, or C?
C.
C, yeah, because that's the one with feet. All right. So come back to this problem. The problem with this is that we're missing two lengths. We don't know this guy, and we don't know this one. That's a problem. Because perimeter, as you told me a second ago, is add up all the sides. So I've got 4 plus 4 plus 8 plus 5. But I'm missing these two lengths right there. How do we find those two lengths?
So I'm not sure if my method is the right one for it, but what I usually do is that I sort of look at it and I sort of figure out, okay, so for instance, the side on the left is sort of an unknown, so the side on the right, where the measures that are both going up are 5 and 4, and
There you
5
go.
plus 4 is 9, so the one on the left should be 9.
There you
And
go.
the same for on the bottom.
So we can take and we can split this into pieces that we know. Like there's a small little square here. So all these side lengths have to be 4. And then over here, this is a rectangle. And you know that opposite sides of rectangles are the same. So this is 5. So just like what you said, all we have to do is add those together. So we know that this missing side right there has to be 9 feet. And the same thing that you just said for down here, we can take and we can split this up. Here's a large rectangle. Opposite sides have to be the same. So this is 4. Again, another rectangle. Opposite sides have to be the same. This is 8. So how long is this side then, April?
12.
There you go. So there's our two missing lengths. So we say plus 12 and plus 9, and that will give us the answer.
Which is 42.
I like it. 42 feet, which we would select choice C for. See, easy peasy. All right, number 17. Number 17.
Quick question. How many
Quick answer.
questions do we have in this test?
25.
Okay.
All right, number 17 is a short little formula. It says, find the sum of the measures of the angles of a three-sided polygon. Okay? So when we talked about this, I gave you a formula that says if you take 180 degrees times n minus 2, that will tell you the sum of all the angles, where n is the number of sides. So it said we had a 3-sided polygon. What is n?
So n equals 3?
Yep. So all we got to do is take 180 degrees times 3 minus 2, and that will be our answer. What's 3 minus 2?
1?
And 1 times 180 is?
180.
Which makes sense because we talked about that earlier, that triangles, which are three-sided figures, have to add up to 180 degrees. Again, this is in 10.3. And now on number 18, we're going to jump into 10.2. Oh, sorry, 10.4. Now we're starting to find area. What kind of figure or polygon do I have over here? What is this?
An obtuse triangle?
It's an obtuse triangle. Good. But more importantly, it's a triangle. What is the area formula for a triangle?
Is it 1/2 base times height?
You got it. 1/2 base times height. Let me draw my triangle real quick. 9.2 yards. The directions on this one also say for our answer, we want to keep it exact. So whatever happens, we're going to take everything that it shows us. Okay. So here's what we got. All we need to do is fill in and then do some multiplying. Who is the base in here?
Would that be 9.2?
That is the 9.2. Who is the height then?
7.6.
7.6. Because remember, the base and the height, as I have talked with everybody, is that your base and height are always connected by a right angle. So this guy right there, there's my right angle. That means this is the height, this is the base. The 8 and the 13.9 are junk answers. So all we need to do is go to our calculator and do some quick multiplying. So alpha y equals for our fraction, we'll put the 1 over the 2. Scroll out, and then I'm going to put a parenthesis, 9.2, close it, and then another parenthesis, 7.6, close it. It's the same way I have it written on my piece of paper. Tell your calculator, enter, and there's our answer. So what are we going to put down?
34.96.
Okay. Because it did say keep it exact, which means no rounding. So 34.96, and this will be yards squared because it is area. Yards squared because it is area. Which I think on this one, which answer will we choose? A, B, or C? Which one will we choose? A, B, or C? Come on, help me out here.
Wait, what's going on?
Which answer are we going to choose? A, B, or C?
Oh, B. Sorry.
B. There we go. All right. 19. We're almost there. Next one. Here is a figure they give us. They want us to find the area again. So again, this is still 10.4. What is this figure they give us?
That's a trapezoid?
It is a trapezoid. What is the area formula for a trapezoid?
I don't think I remember that one.
Okay. So the area formula for a trapezoid is 1/2 parenthesis B1 plus B2 close parenthesis H.
Sorry, could you say that again?
Yep, I'm going to put it up on my screen right now.
Okay, cool.
1/2 parenthesis B1 plus B2 parenthesis H. So base 1 plus base 2 height. So let's fill in. 1/2 times what's B1? What's our first base? What's our base?
Is it not 22?
It is 22. Plus, what's our second base?
$11.
You got it. And then what's the height?
That'd be 6.
Okay. All we got to do is go to our calculator, put this in, let it kick out the number for us. So alpha y equals 1/2. 22 plus 11, close it, and then another parenthesis for the 6. And what's our answer?
99.
99. So 99, what's the label?
Meters.
Meters
Squared.
squared, because it's area. And there you go. And you'll always know the bases, just so I can talk about this, because remember, these are the parallel sides. So your bases are always the parallel sides. So those are my 2 parallel sides in the trapezoid. So that should be 1, B2. And again, this one is a multiple choice. So would you select A, B, or C for the meters squared?
B.
Perfect. Now, number 20. 20 and 21. I think it's, nope. 20 and 22 are going to be alike. Because in this one, there are 4 answers. Okay? The first answer is going to be the exact form, which is going to be in pi. The second answer, you'll round that answer from the calculator. The third answer will again be in pi, terms of pi, exact. And the next answer after that will be rounded, okay, to the nearest tenth. So the first thing is we've got this circle. And we've got this line that goes through the center, and they're saying it's 34 yards. Who is this 34 yards? What is this called?
The diameter.
That is the diameter.
And I was thinking, since the diameter is just twice the radius, wouldn't the answer of the circumference just be the diameter times pi?
And we're going to get to that. Absolutely. Because there are 2 diameter formula, or 2 circumference formulas. But I like what you said a moment ago, that the diameter is 2 radii put together. So if we know the diameter is 34, and that's 2 of my radiuses, how long is 1 radius?
That'd be half of 34, which is 17.
Perfect. So we know the radius is 17 yards. All right. So let's talk circumference. There are 2 formulas for circumference. One of them you just gave me.
The other is 2 pi r.
Pi d, and there's also 2 pi r. So now that we know the diameter and the radius, it doesn't really matter which one we choose. Okay? I'm going to go with this one because it's easy. So to get that first answer, all you need to do is we're just going to plug into pi d, which the diameter is 34. So the circumference is 34 pi yards, because think of circumference as perimeter. It's just around the outside.
Yep.
So there's the answer to part A, which you would choose which letter, A, B, or C?
A.
You got it. Now, for part B, all we're going to do is we're going to put 34 pi in the calculator and round to the nearest tenth. So you push 3, 4. Second, my little caret key. There's 34 pi. Hit enter. Rounded to the nearest tenth. What is the answer?
106.9?
Nope.
Oh.
106 point what?
0.82?
Too many. Just 0.8. Tenth.
0.8.
1 decimal. And that is?
I thought the one's over 5 you round up.
Yeah. But you're looking at the number after it, not the number before it. So
Okay.
1 says, hey, 8, stay the way you are.
Okay.
It's always the number that is after the place you want that dictates what happens.
Mm-hmm.
Watch your rounding. So 106.8 yards. So which one would you select? A, B, or C?
A.
A. And then you'd put the 106.8 in there. So now we want to find area. What's the area formula for a circle? And there's only one.
Is it pi times radius squared?
There you go. Pi r squared. And the cool thing is we found the radius already.
Mm-hmm.
All we're going to do is take and plug the 17 in and square it for part C. Okay? So pi 17 squared. So we go to our calculator. What is 17 squared?
289.
So 289 pi. What's the label?
Yard squared?
Yard squared, because it's area. Good. And so we would select which answer, A, B, or C?
B?
You got it. In part D, all you're going to do is put 289 pi into the calculator and round it to the nearest tenth. And what do we get?
907.9.
You got it. And label?
Yard squared.
Yep. And will we select A, B, or C?
B.
There you go. And there it is. That's how that works. Number 22 is going to be a lot like that, except we'll deal with volume of a cylinder. But it's the same idea. Okay? So let's jump into 21, and then we'll hit 22, and that will end chapter 10, and then we're going to jump back to chapter 9 real quick. So 21, we've got this figure over here. Oh, let me draw this as best as I can. Oh, I just messed that up already. Sorry, give me just a moment. So we're looking for the volume of a cube. Do you remember what the volume formula for a cube is?
No,
Or for a prism like this?
1 second. Yeah, sorry, I don't quite remember
How do you
that.
find volume? Well, easy volume formula that most of you remember is length times width times height. Length times width times the height.
So would that be the 2 times 2 times 2?
Mm-hmm. Or another one, because this is a cube, it's just S cubed, because all your sides are the same. So 2 times 2 times 2, or 2 cubed. What do we get?
8.
8. 8 what? What's the label?
Feet cubed.
Feet cubed, because it's volume. There you go. So we would select A, B, or C.
Oh, that would C.
Okay. Moving on. Number 22. So again, this is like what I was talking about a moment ago. We've got this picture, and we're going to have an exact answer for part A in terms of pi. And then we will have the rounded answer in the second piece for part B. Give me a second. I'm drawing stuff out. From here to there, 7 meters. Okay. So what is the volume formula for a cylinder?
I don't quite remember. Just do that refresh my memory.
Okay. So the volume formula of cylinder is pi r squared h.
Oh, okay.
So for part A, all we got to do is fill in what we know. Do we know what the r is?
7.
Okay. Do we know what the height is?
8.
And that's all you got to fill in. So we're going to have pi 7 squared times 8. So the first thing we need to do is take 7 squared times 8. So 7 times 7 is 49, times 8 is
392.
392 pi meters cubed. Okay? Just like what we did with the circumference and the area. We left it in terms of pi. And so if we come back here, we're going to choose A, B, or C.
We'll choose C.
Okay. And then last but not least, go to your calculator. We'll put 392 pi in, and we're going to round it to the nearest whole number, no decimals. So 392 pi.
Would that be 1,232?
You got it. Because that 5 says, hey, 1, go up. And that would still be meters cubed. So 1,331 meters, or 332 meters cubed. Which one would I choose, A, B, or C?
C.
Perfect. Okay, almost done. So that ends chapter 10. That is all of your geometry. And so now we jump back into chapter 9 with some last minute quick questions. So give me a second to write down what's going on in number 23. Oh, yeah, I'll just jump to a new page. All right, so 23. Back to chapter 9, and this is all coming from 9.1 for this one. This is coming from 9.1, and then 24 and 25, they are coming from 9.3. Oh, and all the one problems down here, The ones where we're doing area up here, 18, 19, and 20, those are all from 10.4. The volume ones that we did at 21 and 22, that was 10.5, if I didn't say that.
Okay.
All right, number 23. We've got quite a few pieces here. So we've got a person's height. We've got the length of a football field.
I'm pretty sure I know what those are.
You what?
I think I know the answer to those.
Good.
I mean,
Length of a bee. The distance from NYC to Washington, D.C. Perimeter of the outside of a house. Length of a car. Width of a book. Altitude of an airplane. The diameter of a screw. And the width of a human foot. All right. So you've got 3 labels here. And in the exam, what's going to happen is these are going to be boxes that you drag and drop in where they go. Okay? They're going to be boxes that you drag and drop in where they go.
all right.
So just to give you some comparisons real quick to make sure that you kind of think about how these things work, because these are English measures, or sorry, metric lengths, and we don't usually use metric here in the United States. Us and about like 2 other countries use English standards, and everyone else is always metric. But millimeter, think tiny, like the length of a pill is measured in millimeters. Meters, think like in feet and yards.
Well, not exactly, because a meter's quite a bit bigger than, it's a little bigger than a yard, so I figure a meter would sort of be like
It is, but
half a
the
person.
closest thing I want you to think about is like yards and feet.
All right.
Okay, kind of give it some context. And then a kilometer, think like miles. Again, it's not exact, but that's the idea. I want you thinking about it, giving you some context behind it. So a person's height, what will we measure that in?
Meters.
You got it. Because it's like feet and yards.
Mhm.
What about the length of a football field?
Also meters.
Yep.
The length of B would be millimeters because these are tiny.
That's right.
And distance to New York City, Washington D.C. would be kilometers because it's quite a big distance. And the
Here we go.
parameter outside has to be meters.
Hold on one second.
Sorry.
I messed up.
Fast.
Nope, you're fine. Nope, I messed up. Give me just one more second. The length of a car
would be in meters.
Mm-hmm.
And the width of a book would be in millimeters.
Mm-hmm.
And the altitude of the airplane would be in kilometers. And diameter of a screw would be millimeters. and the width of the human foot would be in millimeters.
You got it. Very good. So all this is on the exam, it's a drag and drop type scenario.
Yep.
Perfect. Just writing down all the answers and boxing them in on this one on my sheet of paper. I love it. All right. 23 or 24.
24.
Comes from 9-3, and the same thing for number 25, 9-3. So in this one, it's very much like what you just did in 23, except it's weight. So if we wanted to measure the weight of a dog, would we do it in milligram, gram, kilograms, or ton?
Kilogram?
It is kilogram.
Speaking of kilograms, did you ever see that one video of that one Irish guy being explained to that a kilogram of steel weighs the same as a kilogram of feathers? It's pretty funny.
Oh, yeah.
They keep saying,
Yep.
but I don't understand, feathers weigh more. They're like, no, but it's the same amount, so it weighs the same.
So it's the same weight. So yeah, kilogram, think about it like pounds. We weigh dogs in pounds.
Mm-hmm.
Milligrams, again, think like pills. Pills are measured in milligrams.
Mm-hmm.
Okay, their weight, because they're very, very light. A ton, and that should actually be tonne. There should be an NE on the end of it, because that's the English, or sorry, the metric version. But yeah, tons is huge. Like whales are measured in tons. And then grams is a little tougher to kind of conceptualize because a gram is still very, very light. There's not much to grams. So like when it comes to like a gram, I think about like a teaspoon of something would be like a gram. It's a little bit more than a pill, but it's not as, like it's nowhere near a pound.
I get what you're saying.
So, but yeah, that's kind of how I think about it. All right, last but not least, number 25, a small little word problem. I'm going to go to a new page for that one. All right, number 25. This is it, last one. So in this one, you got to be careful because there's a couple things that you got to do. You got to jump through a couple hoops, okay? So it said the prescribed dosage of a drug is 12 milligrams per kilogram daily, meaning that 12 milligrams of the drug should be administered daily for each kilogram of a patient's weight. How many 100 milligram tablets should be given each day to a patient who weighs 163 pounds? Fact, 1 pound is about 0.45 kilograms. Okay, so what is the first thing we have to do? Because there are really 3 steps to this problem. What do we need to figure out first? Sorry, excuse me.
So the prescribed dosage is 12 milligrams per kilograms daily.
Mm-hmm.
Being at 12 milligrams be administered daily. But the tablets are 100 milligrams each.
Mm-hmm.
So 112. And the patient weighs 160 pounds. So we should probably convert pounds to kilograms first.
There we go. That's the first thing. Convert from pounds to kilograms. So we know the guy is 163 pounds. In the end, we want to be kilograms. And we have a little conversion there that says 1 pound is about 0.45 kilograms.
I keep forgetting,
Okay.
do I multiply or divide? Because I multiplied and I got some.
Well, remember, we use dimensional analysis, so it's always multiplying. Just the question is, what's the number you're multiplying by? Is it a fraction or is it something else? So what label goes in the denominator? Who are we getting rid of?
Getting rid of the pounds.
Okay. That means kilogram goes on top, and now you know what the fraction looks like. 1 is on the bottom with pounds, and 0.45 is in the numerator with the kilograms. So in the end, you're really just taking 163 times 0.45.
Okay, so did that. I got 73.35. Do I have to round it?
No, do not round.
Okay.
No rounding until the very end, because otherwise that would be bad math. So our patient weighs 73.35 kilograms. Okay. Now, what are we going to do with this? We know how many kilograms the patient is. What do we do now?
So the patient weighs 73.35. So 12 for each kilogram. Do you multiply 73.35 times 12?
That's right. We need to figure out how many milligrams the patient needs. So figure out number of milligrams of medicine. So we're going to, hold on one second.
808.2.
Okay. So you took the 73.35
Yep.
kilograms, and what you're really doing is you're converting that to milligrams, because we have this conversion that's right here that says 12 milligrams per kilogram. That right there is a conversion in disguise for us. Looks like this. So that 12 kilograms or 12 milligrams per kilogram is really 12 milligrams equal to 1 kilogram. This is for the medicine. And so we're just going to take, like what you said, the 73.35 times 12. And what did you get again?
808.2.
You got it. So this patient needs 880.2 milligrams. Okay. So now we're on the last piece here. So last piece, what are we figuring out now?
Last piece. So the patient should receive 808.2 milligrams each day. So I have to round the nearest whole number. Would that mean make it 881?
No, we're not there yet. There's one more step we got to do.
How many 100 milligram tablets? Oh, so how many 100 milligram tablets?
You got it. We got to figure out how many tablets.
8. So that'd be 8 tablets?
Well, hold on. So the last piece is we got to figure out the number of tablets. And we know that one tablet is 100 milligrams.
Oh, so we divide 880.2 by 100?
You got it. So again, it's like a little conversion again. We've got 880.2 milligrams. In the end, we want to know tablets.
So I got 8.802 is basically just moving this point left, essentially.
Mm-hmm. So 8.802, right? And now follow the directions. It says round to the nearest whole number. So what's the nearest whole number?
8?
Nope.
No. Oh, would that be 9?
It is 9.
9 tablets.
Watch the rounding. And there you go. Because this 8 says, hey, 8, go up. So the patient is going to get 9 tablets per day.
All right.
And that right there wraps up exam 2. That's what it looks like. That's how it plays out. Watch your rounding. Be careful of problems. Like I said, the ones that generally give people trouble, number 9, number 11, and the number 25 tend to give people trouble. If you watch out for those, you guys are going to be just fine.
Mm-hmm.
Any questions?
No, I'm good.
Okay. I'm going to pause the video.